Guys, this is Miss Morell, and I'm here with your recap of instruction from Monday and Tuesday, September 14th and 15th. So we spent a lot of class time on these days preparing you for your summative quiz that'll be coming up on Wednesday and Thursday, the 16th and 17th. And to do that, we spent some time comparing graphs because it kind of ties everything together. So let's remember that speed is distance divided by time. And velocity is simply speed with direction. And acceleration is simply any change in speed. There are three ways that speed can change. An object can speed up, an object can slow down, an object can change direction. So any of those changes are acceleration. So a change in speed or direction, don't forget, is always caused by unbalanced forces. So hopefully by now you know the first thing to do when you get a graph is to look at the labels. What do the labels tell you? What kind of graph is it? So in this case, I know some of this looks kind of complicated. Don't worry about gradient and all of that. But what I want you to see is this one is a distance speed, a distance time graph. So this is distance and then time over here on the x-axis. So dt, that makes it speed, distance divided by time. This column, these are speed graphs, velocity, so speed with direction. And this is also time. And then this column are acceleration graphs. So acceleration as time goes by. So here's time, as always, on the x-axis. So let's compare what things look like in each of these graphs. In a speed graph, if you have a straight horizontal line in the graph plane itself, distance is not changing. So that means the object is sitting still. If the object were, if distance were changing, like there were a gradient difference in the points on the line, the distance value is changing, so you know it's moving in some direction. So in this case, it's not changing, so this object is sitting still. On a velocity graph, notice you have the same horizontal line, but speed equals 0. So over here, it was distance wherever you are, but it's not changing. Here, it's speed equals 0. That means there is no motion. It's sitting still. And same on an acceleration graph. On an acceleration graph, it's down here where speed equals 0 because there's no change in that speed. So now let's look and see what constant speed looks like on each of these three graphs. On a distance time graph, you have a nice straight line or originating from the origin and going straight up diagonally to the right. So this tells you that you are traveling at a constant speed. So at any point along that line, you could plug those values, speed equals distance divided by time, into that formula, and they would be the same because that straight line indicates constant speed. So on this graph, however, velocity, here, speed is not changing. So this one is like you have your cruise control set. It's constant. And then down here, when it's a straight line on an acceleration graph, it's still at 0 because there is no change in direction. The speed is constant. So what I need you to see is the difference in the placement of the line for a speed graph and a velocity graph. Up here, in the speed graph, it's originating from a point and going straight up diagonally because distance is continuing to change as time goes by. So that line goes diagonally positive. On a velocity graph, the speed is what's on the y-axis and it's not changing. It's that constant speed, so that line doesn't change. And then over on acceleration, because there's no change, acceleration is 0. So then when we have a change in our speed, like we're speeding up, we're accelerating, we're going faster. On a speed distance time graph, we've got a curved line. On a velocity graph, that's when you get your speed is increasing uniformly, constantly, but it's increasing. And then here on an acceleration graph, as time goes by, your speed is increasing, but it's increasing at the same rate. So the acceleration rate is constant. So you're not sitting down here at zero anymore. You're going faster, but it's going faster at a constant rate. So hopefully that kind of clarifies some of that information for you on speed graphs. And then we spent the rest of the class period helping you review. We went over the learning targets. We looked at the unit overviews. We played some vocabulary games and encouraged you to look at your vocabulary, and we reviewed your science journal. So hopefully you will go home and do that and study for your test. That's your recap for Monday, Tuesday, September 14th and 15th. And I hope this gets you where you need to be.